Stop the video and take a minute to read through the problem. I want to note that we have a domain. X is between 1 and 40. We're given revenue and we're given cost. All right, part A, determine where revenue equals cost. Okay, that's this first part. Revenue equals cost, revenue equals cost. That's going to be X 50 minus 1.25x equals 160 plus 10x. So that's 50x minus 1.25 x squared. 50x minus 1.25 x squared equals 160 plus 10x. That's quadratic, so get 0 on one side. Negative 1.25 x squared. Subtract 10x from both sides. 40x minus 160 equals 0. Our leading coefficient is negative 1.25. I believe every term is divisible. I know they are. Every term is divisible by 1.25. So let's divide all the terms by negative 1.25 and clean this thing up. And that gives me x squared minus 32x plus 128 equals 0. And I don't know how to factor that, so I'm going to use a quadratic formula. X equals negative b. Negative of a negative, 32 is positive. 32 plus or minus the square root of a negative 32 squared minus 4 times 1 times c, which is 128, divided by 2 times a, which is just 2. So I used my calculator and I got x to be about 4.7, I'm rounding, or x is 27.3. Okay, so that's where revenue equals cost. All right, where is R less than C? Well, R, I'm going to go ahead and distribute that x through there, is negative 1.25 x squared plus 50x less than cost is 160 plus 10x. And if you need to get 0 on the right hand side because we have an inequality, and if you divide everything by negative 1.25x, you're going to end up with x squared minus 32x plus 128 is greater than 0 because I've divided everything by negative 1.25. When you divide an inequality by negative, you have to reverse the symbol. So this is my standard form. Now I skipped several steps to go from that first line to the second line. Now, if we find our critical numbers, we set this equal to 0, and we've already done that. We did that in the part above, and that was x equal 4.7 and x equal 27.3. So the next thing you do is you take your critical numbers and you put them on the number line. So that's 4.7 and 27.3. Where's 0? 0 is in the far left. If I plug 0 in here, I'm left with a positive number. So this is positive. And then, take the number 10 and plug it in for the middle region, and you're going to get a negative number, and then that's going to be positive. So now you look back at your standard form. I want numbers greater than 0. That means I want numbers that are positive. So where are numbers positive? Let me go back and look at x is in between 1 and 40, okay? So this range is positive, and the one on the far right is positive. So you would think you'd start at negative infinity, but in the business world, negative infinity really doesn't make a lot of sense, particularly for x, where x is number of units. Started this at 1, And so it's going to be 1 up to 4.7, or you could say 5, if you're going to round that, union. This is a parenthesis because it's greater than, not greater than, equal to. Union, this top part, 27.3, it's only going to go up to 40 because of domain. Now I'm putting brackets on the 40 and the 1 because look, you've got less than or equal to, less than or equal to. And revenue greater than cost, well, that's going to be the opposite place of revenue less than cost. It's going to be, if you manipulate the equation, it'll be x squared minus 32x plus 128 is less than 0. And it's less than 0, which is negative in between. It's this middle region. So that's between 5, interval notation, starts at 5, rounded, and goes up to 27. And I believe we have another page. Yes. But my domain determined the maximum revenue. Well, do I have my revenue equation? Yes. My revenue equation, R of X, my revenue equation is negative 1.25 x squared plus 50x. Maximum, this makes sense. This is a parabola, it opens down. Vertex will be at the maximum. Vertex is negative b over 2a. That's negative b, or negative 50 over 2 times a, which is negative 1.25. Use your calculator, and I got 20 units. All right, what is the wholesale price of the radio at this point? Now, you might say, hey, I don't have a price equation. But if you look back on the first page, revenue was given as x times 50 minus 1.25x. X times P, there's your P. P is 50 minus 1.5x. Remember, revenue is defined as X times P. So now I want to plug in 20, because this is what is the wholesale price of the radio at this output being 20. 50 minus 1.5 times 20. And I use my calculator, and I got a price of 25. All right. Now, we are going to graph this thing. It's going to be in the first quadrant, where x and y are both positive. And I'm going to make my units like this. 300, 400, 500, 600. Okay, graph the cost function and the revenue function simultaneously. Okay, and 1, 2, 3, 4, 1, 2, 3, 4. X, of course, is my units. 1, 2, 3, 4, 20. 1, 2, 3, 4, 30. 1, 2, 3, 4, 40. All right, if you look back at the first page, part where we let revenue equal cost, that will be the intersection points where x is 4.7 or x equals 27.3. My cost equation is 10x plus 160. That was also given. I'm going to do some ordered pairs. X and c of x, which is just y. If x is 0, you get 160. If x is 40, I'm choosing 40 because that's the upper part of a domain. Plug 40 in my cost equation, you get 560. So 0, 160 is about right here. And 40, 560, 40, 560, 40, 560 is about right in the middle of my point. Let me get another color. Here and here. And I'm going to freehand this, and we'll see how close this goes. Ooh. Close enough. I'm stopping at 40 because of my domain. Now, we have the vertex, don't we? The vertex is 20 units. And I'm graphing my revenue now. R of 20 was 500. Did I find that? No, I didn't find the maximum revenue. Let me do that. R of 20, plug 20 in your revenue equation, and you get 500. So that's my vertex, 20, 500. 20 up 500 is here. And then the revenue equation, R of X is negative 1.25 X squared plus 50X. If I did some ordered pairs, if X is 0, Y is 0. So I'm going to plug that point there. And let's use symmetry. Halfway through the units is 20. From this point to this one is 20 units. So I know 20 units on the other side, I will also have a point. Now, we found, let me see, that part where revenue equals cost, we had X equal 4.7, which is about there, and X equal 27.3. That's 20, let me see, 27, I don't know, somewhere right there. So if I connect my dots, that looks pretty good. There's my graph. So what's important here, this is revenue, and this is cost. And where revenue is greater than cost, you have profit. And I've got a loss in these other regions because the cost is greater than revenue.